How can we prove that the Earth is actually spinning? Do we know for a fact that the Earth is spinning? After all, we watch the sunrise and sunset and we have no sensation of any movement. So if the Earth is spinning, is it possible to detect its spin using equipment? In fact, all airliners have equipment on board that detect the Earth's spin extremely accurately and determine its location using this information. With millions of people flying in on aircraft on a daily basis, aircraft safety is a high priority, and therefore all airliners have multiple layers of redundancy. This includes navigation equipment. So all aircraft, aside from having recent advancement in GPS technology, also carry navigation equipment that use laser gyroscopes that can detect the slightest movement of the aircraft.
IRS uses ring laser gyros, which have no moving parts. Over the last 40 years, it has become possible to miniaturize lasers down to a size small enough to use in aircraft. Look at the pattern of the laser light, which is shown in yellow here. This is a picture of an IRS inertial reference unit. It is mounted in the aircraft with this end facing the front. You can recognize that laser light pattern. Two of the laser gyros are easy to see. Here is the gyro which measures pitch. This one measures yaw. But you can also see a little spot of light here. This is the third gyro, set at right angles to both the other two. This one measures roll. These ring laser gyros are not gimbaled. They are fixed to the airframe, and they change their orientation as the aircraft maneuvers. The accelerometers are also in fixed positions: longitudinal, lateral, and normal or vertical with respect to the airframe. A system where the gyros and accelerometers are fixed to the airframe and maneuver with it is called a strap-down system. This is in contrast to INS, which was a gimbaled system. The ring laser gyro measures angular rotation. Unlike previous methods, there is no system of comparing a gyro with gimbals in order to measure an angle. It is a completely new principle to us, and it depends on a property of light known as the Sagnac effect.
In 1913, Sagnac carried out a simple experiment of passing light in opposite directions around a table and recombining them. This produced interference fringes. He then rotated the whole table at 2 revolutions per second and found that the fringes changed. This result has very significant implications in science. It works as follows. A beam of light leaves the light source at the bottom left-hand corner and is split into 2 different beams, which we have coloured red and blue just to distinguish them. They travel round the circuit in opposite directions until they eventually reach the splitter, which also recombines them. There they then go on to the photographic plate, where they have interference fringes. In this simplified version, we see that the beam is split into 2, the red and the blue again, and they go round the circuit and are recombined at the splitter and recombining prism, so that they again produce the fringes on the photographic plate. Now let us rotate the table. Before we do so, there is the very important subject of the effect of the ether. The Michelson-Morley experiment failed to detect the 30 kilometers per second motion of the Earth through the ether. So as to overcome this problem, Einstein simply abolished the ether in his relativity theory. The very significant result of the Sagnac experiment was that it proved that the ether existed. Let us see how it did this. It is a fundamental feature of relativity that it claims that as there is no ether, light travels away from a source at the same speed relative to the source, whether the source is moving or not. Thus, whether the table is turning or not, the fringe patterns should stay the same. But if the ether exists, once the light has left the source, the speed of the light is controlled by the ether, independent of the speed of the table, mirrors, etc., as we see here. So let us see what happens when we rotate the table. Here, the light is split, and the red and blue lights go in opposite directions. But notice that the left-hand mirror has moved around in such a direction that the distance the red light has to travel is further. Now in relativity, the same time should be taken because the splitter is also moving and the distance between them is the same. But now imagine that the ether exists and the speed of the light is controlled by the stationary ether. Imagine the ether like a thick treacle that limits how fast the light can travel, independent of the motion of the light source, the splitter, or the mirrors. The result is that the red light takes longer to reach the left-hand mirror. Similarly, the right-hand mirror is coming towards the blue light, so it reaches the mirror quicker. After they change ends, the red light again takes longer to reach the recombiner, whilst the blue light gets there quicker again. So they reach the photographic plate with a delay between them, and this changes the fringe pattern. In fact, Sagnac, using the speed of the rotation of the table, calculated how much the fringes should change, and found that they did change by just that amount. How does the scientific establishment deal with this result? By muddying the waters with scientific gobbledygook. Wikipedia says, in the above discussion, the rotation mentioned is a rotation with respect to an inertial reference frame. Since this experiment does not involve a relativistic velocity, the same wording is valid both in the context of classical electrodynamics and special relativity. How on earth can it be valid in both theories? It clearly proves that the ether exists because the speed of the light is controlled by the ether, independent of the rotating table and mirrors. This Sagnac effect is used by airlines for their compass directions. As the plane turns, the change in the fringes are translated into a change in the direction of the plane that then registers on the cockpit compass. In addition, I have received comments from 2 scientists complaining that they were never taught about the Sagnac experiment. The first said, "After 35 years as a professional physicist with a thesis in relativity, I only learned of Sagnac's experiment last year." Another correspondent complained that his professors never mentioned these important experiments. Dear Mr. Bowden, thank you for your enjoyable and well-written website. I've enjoyed visiting there today. I was especially interested in your comments on geocentricity, which, as noted, are controversial. The amazing thing is that none of the experiments cited were ever discussed in my undergraduate education, nor the implications cited. All my life I have heard the story of how Copernicus's theory came to prevail. I would have thought that major experimental evidence, already in existence, and calling the theory into question, would have at least been cited. One feels cheated as a student, of course, to keep finding 25 years later these bodies of contrarian evidence that never are mentioned in the classroom unless a student has already researched the topics and brings them up. Yet again, we have the suppression of scientific evidence that supports creation and geocentricity.
In these next few sequences, I would like to just show basically how the gyros within a IRS setup are laid out and which one is responsible for the rotation detection. So basically here, the one that's laying down flat perpendicular to the earth, and in all the following sequences showing these three gyros, is basically the one responsible for that rotation. If these gyros are so precise and so sensitive that as you saw earlier in the Cynical effect, it's capable of detecting the most minute rotation of the Earth at a 15 degree an hour rotation. How come they do not detect a much bigger movement like the Earth going around the Sun, which is not just a constant, but as you can see in this image here, the Earth is rotating counterclockwise once a day at 1,000 miles an hour, as it is at the same time going around the Sun at 67,000 miles an hour. During the day, the Earth is going against that 67,000 miles an hour, not on at a constant speed because it's an orbital movement, but you can subtract 1,000 miles an hour from the 67, and that will give you a 66,000 miles an hour speed during the day, and then you have to add 1,000 miles an hour during the evening and night as you're going now with the rotation of the Earth around the Sun for a whopping 68,000 miles an hour. So a differential of 2,000 miles an hour from day to night, and you tell me that this super sensitive gyros cannot detect the change in speed and movement, acceleration and deceleration of this movement from day and night. So basically that's what I want to leave this. Thanks for watching the video. Leave any comments below, and I'll see you guys on the next one. Thank you.